What if Earth lost its atmosphere? Imagine you are standing outside, the sky is blue, you can breathe, you can hear the wind, clouds are moving overhead, and then the entire atmosphere disappears. Not gradually, not over thousands of years. Instantly, every molecule of nitrogen, oxygen, water vapor, carbon dioxide surrounding Earth is simply gone. What happens next? And more importantly, how long would Earth survive? The first few seconds. The first thing you'd notice isn't the temperature, it's the silence. Sound needs a medium like air to travel through. With no atmosphere, there would be no air carrying sound waves. So, if someone screamed right next to you, you wouldn't hear them. At the same time, the pressure around you would suddenly drop from roughly 1 atmosphere at sea level to almost 0. That's essentially a vacuum, and your body is absolutely not designed for that. The air inside your lungs would rapidly expand and escape. Water in your exposed tissues will also begin to vaporize at the body temperature because boiling depends on pressure, not simply temperature. In fact, at pressure low enough, water can boil even when it's nowhere near 100 degrees Celsius. At around 19 kilometers above Earth, atmospheric pressure is already low enough that unprotected body fluids can boil. So, on an atmosphere-free Earth, the problem isn't that your blood suddenly reaches 100 degrees. The pressure disappears, your body would swell, gas would expand, and without immediate protection, you'd lose consciousness from lack of oxygen within seconds. But humans wouldn't be the only ones in trouble, because now Earth itself has changed. The sky would vanish. Look up, there would be no blue sky, no clouds, no sunset. Instead, even in the middle of day, the sky would appear black. Why? Because the blue sky isn't the natural color of space. It's caused by sunlight scattering through Earth's atmosphere. Remove the atmosphere, there's nothing left to scatter sunlight across the sky. The sun would still be shining. It would just look like a brilliant disk against black space. And the stars, you could potentially see them during daytime too. Because there would be no atmosphere washing out the background sky, it would look less like Earth and more like standing on the moon. And that's actually an important clue, because the moon has essentially no substantial atmosphere and its surface experiences enormous temperature swings between sunlight and darkness. Earth would begin heading towards a similar kind of world. But here's where it gets really bad. The atmosphere isn't just something we breathe, it's one of Earth's biggest thermal blankets. Greenhouse gases, especially water vapor and carbon dioxide, helps Earth keep warmer by absorbing and re-emitting infrared radiation. Without an atmosphere, Earth's surface would lose a major part of that insulating effect. But don't imagine Earth suddenly becoming an ice ball. That's a common misconception. The ocean contains an enormous amount of heat, and Earth's surface wouldn't respond instantly to changes in the atmospheric conditions, so the planet wouldn't suddenly freeze solid in seconds. Instead, the climate system would begin collapsing. And there is another problem: the water. This is where the vacuum gets really strange. At normal sea level pressure, water boils at 100 degrees Celsius, but lower the pressure enough and it boils at a much lower temperature. With almost no atmospheric pressure, liquid water at Earth's surface would be unstable. Water exposed directly to the vacuum would begin to boil and evaporate. But here's the twist: boiling itself cools things down. As water molecules escape into vapor, they carry energy away. So, some surface water would rapidly cool and freeze. You could actually get a bizarre combination: water boiling and freezing at the same time. The exposed surface of oceans would begin losing water to space. Some water vapor would eventually escape Earth's gravity, while some could freeze. Over time, Earth's surface reservoirs would lose water, but the ocean wouldn't simply disappear in one giant explosion. Earth's oceans are enormous, and the deep ocean is protected by water above it and by the thermal inertia of the planet. So the transformation would take time. The surface would become increasingly hostile, and the water cycle is gone. No atmospheric water vapor, no clouds, no rain, no snow, no hurricane, no weather. Earth's famous blue sky would be replaced by a black one. And then something even more important happens. Plants need carbon dioxide. They use it during photosynthesis to turn light energy into chemical energy. Remove the atmosphere, CO2 is gone. Photosynthesis on land would collapse. Plants could no longer maintain their normal metabolism and the food chain starts breaking apart. Herbivores depends on plants, carnivores depends on herbivores. Humans depend on both the ecosystem and agriculture. And unlike the atmosphere disappearing, this part wouldn't happen instantly. It would unfold as Earth's biological system lost the conditions they evolved to depend on. But there's another inevitable disaster happening above us. The sun gets much more dangerous. Earth's atmosphere normally protects life from harmful ultraviolet radiation. The ozone layer in particular absorbs much of sun's dangerous ultraviolet radiation. Remove the atmosphere and you remove the protection. The surface would be exposed directly to the harsh space environment. And there's an important distinction here. Earth's magnetic field wouldn't automatically disappear. The magnetic field is generated primarily by processes inside the Earth's outer core, not by the atmosphere. So even an atmosphere-free Earth would still have a magnetic field. But the magnetic field isn't a replacement for the atmosphere. The atmosphere and the magnetic field protect Earth in different ways. The magnetic field helps deflect many charged particles from the solar wind. The atmosphere provides mass that absorbs and scatters radiation and protects the surface from many incoming particles and radiation. Without the atmosphere, the surface would be dramatically more exposed. And there's one more thing that atmosphere normally does, and you won't think about it. It acts like a shield. Every day, tiny particles from space enter Earth's atmosphere. Many meteoroids burn up because of the collision with the atmospheric molecules. That's why you see shooting stars. They're not at all stars. They're bits of space rock heating up as they move through the atmosphere. Remove the atmosphere and there is no atmospheric shield to slow and heat most incoming meteoroids. Small objects that would normally burn reach the surface would now reach easily. Earth wouldn't suddenly be bombarded by giant asteroids, but the planet would lose one of its most important protective layers. And now we can zoom out because something even stranger has happened. Earth would still be orbiting the sun. Losing the atmosphere wouldn't make Earth fall into the sun. It wouldn't stop Earth's rotation. It wouldn't destroy the planet's gravity. The solid Earth would still be there. The oceans would still exist, at least initially. The moon will still orbit Earth. Earth would still orbit the sun. The planet itself wouldn't have exploded, but the world on its surface would be almost unrecognizable, and eventually Earth would become something like a dead, airless world. And now the important question, could anything survive? Maybe. And this is where the answer gets more interesting. Life doesn't necessarily require Earth's surface conditions. Some microorganisms live in extreme environments today, deep beneath the ground. Organisms can survive without sunlight. The deep ocean contains ecosystems that don't depend directly on photosynthesis at the surface. If the atmosphere vanished instantly, many surface ecosystems would collapse, but it would be wrong to say all life would immediately die. Some organisms deep underground or in protected environments might survive for much longer, and if humans had enough warning, we could potentially survive inside sealed, pressurized habitats with artificial oxygen and controlled temperatures. In other words, Earth wouldn't necessarily become lifeless immediately. It would become a planet where life could survive only in isolated pockets. The surface itself would be the problem. And here's the most terrifying part. The atmosphere is surprisingly thin. NASA describes it as an extremely thin sheet of gas surrounding the planet. If Earth were the size of a baseball, or let's say a basketball, the atmosphere would be comparable to a thin, tightly held pillowcase. And that's all that separates the surface from the vacuum of space. And yet, that thin layer does almost everything we would take for granted. It gives us oxygen, it provides pressure, it drives weather, it powers the water cycle, it helps regulate temperature, it blocks much of sun's harmful radiation, burns up many incoming meteoroids, and it makes Earth look like the blue planet we know. Take it away, the Earth doesn't explode, it doesn't disappear, it simply becomes a world that is almost completely hostile to life on its surface. So the next time you walk outside, feel the wind, listen to it, because that invisible ocean of gas surrounding you isn't just empty space. It's the reason you can hear the wind in the first place, and without it, Earth would really feel like Earth not at all.